Hello everyone, welcome to LearnOverflow. In this video, we'll see today's LeetCode problem. There is a maximum sum rectangle no longer than k. This is a hard type problem and we'll understand what this question is. So first of all, this question is actually a combination of two different medium level questions. The first one is maximum sum rectangle in a 2D matrix or in a single matrix. You can go ahead with, but in a 2D matrix. So that the first question is like maximum sum rectangle. And the second question we need to look is maximum subarray sum. Okay, so maximum subarray sum is also an LeetCode problem. These are two different questions that are available. So whenever you see maximum subarray sum, remember those subarray sum is always comes with no larger than k. Okay, so whenever those kind of questions like maximum subarray sum comes up, we should think on something based on the Kadane algorithm. So Kadane algorithm is pretty popular algorithm. You should see on like a 1D matrix or 1D array in that. So that's the two questions that sums up this question, and thus it makes it a bit hard for us. Okay, but it won't be hard at the end of the video. I'll make sure that you understand each bit of this question. Okay, so that will be our approach over here. So now first let's look at like what are the question tells us. The question says M and N are two matrix like M cross N a matrix given to us. That's a matrix. Okay. So it makes sure that this is not an square matrix. Okay, so that's what it determines. So further, it's like there's an integer k is there. Fine, there's an integer k, and we need to return the maximum sum of rectangle in a matrix such that its sum is no longer than k. So we need to check for like maximum sum, so that is sum is no longer than k. Okay, so let me just quickly write this. Give an example: 101 in the first case, and then 0, -2, and then 3. That's the second row. So let's see what's the maximum summary sum. Our k is given over here. Right? Our k is given something like 2, right? So that's the 2 k being given over here, right? Now, what will happen? See, we can go something like we should start. Anyways, we should start from the 0, 0 position of the matrix, like the with this box. Okay. Now, this box itself is a rectangle. Remember, this doesn't make. They don't tell you that this is not a rectangle because each of the indexes of each of the box itself is a rectangle, and we need to check. Like if we go ahead with only this one, this is like 1, and this is 1 is always less than equal to k. That is the 2. Fine. I find that if we select only the one box like 3, so if I 3 is it less than equal to 2? No, this is not the case. So we find that we can go ahead with a combination. Okay, so each of the boxes can also be a case, or we should go keep checking for the combination. Now, what if we check for something like this? Say we took this 1 and then 0 and then 1. So if we take this first row itself, what we find? We find that the sum is like the whole row sum is like 2. Okay, and that 2 itself is becomes equal to our k, right? That is k is like 2 given to us. That's the 2. So we find it can be equal. So also in the other case, what can be the case? See, it's like 0 is there. Okay, 0, 1, -2, and 3. If we take this particular rectangle, the one I'm marking green. So if we take this particular rectangle, that will be like 0 plus 1 plus 2 like -2. Okay, and then plus 3. So what that becomes? That becomes our 2 in our case. Okay, so 2 that is also less than equal to our k, right? That is actually equal to k, but that is by condition it is less than or equal to k, right? So it may happen that there can be multiple like maximum values we can reach from here. Okay, so that's also possible. So how we should approach a question like this? Once we need to approach a question like this, we need to see what can be our approaches over here. So we should like keep on checking like each of the columns. Okay, we should keep on checking each of the columns and then find something like cumulative sums of each of the columns to find out which one is actually helpful for us. Fine. Let's see. Let's just erase this off and let's see what we actually mean by that. So by default, we have 1, 0, and then 1. So that's the array. I'm just writing it down. Then 0, -2, and then 3. So that's the array given to us. Fine. Now for us, k is something like 2 is given for a k. Fine. So that's the question. Now what will be our approach to find these questions? We'll first take 2 pointers over here. Fine. What do the 2 pointers do? The 2 pointers will be one is left. Fine. One is left, the other one is right. So left and right are basically storing the the indexes we are like particular row the particular columns we are trying to check. Now for each of the columns, what we'll do, we'll keep a array additional to us. The array length will be the number of rows we have in our particular column, each of the columns. So how many rows are there in our first column or any of the columns? You know there's like 2 rows, so this array will be 2. Now how will we go ahead we'll check first like left being so left being at the initial position over here, right? And also right being initially at the first position wherever the left is, fine. Now we'll check the like for each of the row we'll keep on finding the sum. So what is the initial values we have? 1 and 0. That's the 1 being on the first row and 0 being on the second row. Now if we move ahead, how we'll move back, then the next step what will happen, our particular R we have, right? The particular R we have, this R will move from here and this R will move to the next row, right? R will move over here. Now what will happen, we'll add this sum, we'll make a sum of this. So here R is moving over here. Now we'll make a sum with our this sum array, like the array we are doing. So what we do, our objective is not to change this initial array. So we took another array to find our find our value we are trying to find. So we will find this R and then we'll check. We'll keep a sum. So 1 plus 0, so that's 0 itself, and 0 plus our minus 2. This is the value we come across, right? So on each step, like on each step we are adding those values, right? And we'll check for what? We'll check for a value something like is it anyway less than equal to 2? We'll find that 1 plus 0, that is 1 itself, the sum is 1, is actually less than equal to 2. That's possible. And also we find like this 0 plus minus 2 is actually minus 2, which is also less than equal to 2, right? But we need to find the maximum sum of rectangle, right? So what is the maximum sum at our current position? Our maximum sum is like 1. So we'll have another variable like maximum sum. To be exact, this particular logic for finding the maximum sum we'll discuss in next step. But first step is to know how we should traverse our array and go inside it, like break through it. Fine. Now the maximum sum we need to check on the basis of whether we will take 1 or we will take this 2, like minus 2 or whatever other values that there in our array. Right? We need to check basis on that. But initially we are just by looking at that how we are traversing, we find the maximum sum is something like 1 till now. So next we will move our R from here till to the next position. So R is over here, fine. R over here in the next step, and that is pointing the third column. Now we'll add this current value. So 0 plus 1 will be our next value we got added, right? And then we find that in this row we find 3 being added over here, right? So what is the current value of the first column? We find 2. So is it 2 is less than equal to our k? Yes, true. So the maximum sum becomes 2. And here we find 3 minus 2 is 1. So 1 is also less than equal to k. But we need to find the maximum sum. So by default, by looking at that, we find the maximum sum is 2. As I said, we'll discuss the maximum sum in a next step. Fine. The next step we'll discuss 2-3 minutes later. But now let's understand how we're traversing through the array first. We'll just find out how we are going ahead with. Fine. Now, after that, once we reach the end with our right, we have just found a cumulative sum of each of the row starting from 0 till the end. But it may not be the case. Why is it so? We may have to find a cumulative sum of the row starting from this till the end, right? That's exactly the one example shown in our example 1, right? So we need to find starting from this to end. So what will be the next step? L will change from here and it will move to the next element. Like once R on the right pointer reaches the end, our left pointer will move from the first step and keep moving ahead. So now L, the left pointer points there, and once left pointer points there, initially our right pointer will also be here. Fine, that's the initial case. And now we will initialize our this particular array, this particular maximum sum array. We are like a row sum array we are doing. So we'll initialize this as well. So this won't be the value. Fine, this will initialize this. And what's the next value? The next value is 0, and the next value is 1. So that's what we find. And then R will again move from this to this, and then we find 0 plus 1 is our value, and then this 1 plus 3 is our next value. Fine. So 1 plus 3 is our next value. Fine. So that's a what did I do? Oh, wait. I just made a small mistake over here. It's not 1 plus 3. Okay. So what we initially do, we are going row wise. So it's like 0 is in the first case and minus 2 is in the second row. And then in the next step, when R moves to the next row, it will be like plus 1, and then it's like plus 3. Okay. So that's been added. So once we do this, what becomes our maximum value over here? Maximum value is like 0 plus 1 is 1, and this one is also 1. But remember, we already found maximum value being 2 right now. So once we find 2, we won't replace that with our previous value, right? That's the obvious idea for us. Now, for each of the case, we find that we will keep traversing in this order till we reach the end, like till we reach each of the single element and each of the covered up element as well. like each of the whole row leaving one element, leaving two elements. Okay, so this way our approach will keep on going. So that's how we find the initially we find the maximum value. So what will be our loops? If you just look carefully, what will be our loops for us? So our loops will like, if I just erase this in a moment. So our loops will traverse something like, our left pointer will traverse from like zero, right, from the zero equation till the end, right, till like end of the like the columns, like how many columns till the end column. Okay, and our right pointer will traverse from I, it is initial position is I, till the end of the columns, right? So that's what our right pointer is, right? And also we traverse one more thing is our this particular row. Okay, this particular row is keeping a track of all the rows. So that's a row is another variable. So you can find that this is going on in a like order of n into n. Like if there are n values, so n into n into each of the rows being how many m is there, right? Like if the m value is 2 and n value is 3, so it's like 3 into 3 into 2. So that's the current condition we find. So this row will traverse for each of the rows. How many rows are there? How many rows being from the 0th row till the row like the column this column end. Okay, so the row end will mark that because we are taking it as each of the rows being covered. Fine. So that's our traversal. Now within each of the rows, we need to check for an important condition. We need to check for what? We need to check for our maximum sum, right? The maximum sum of our rectangle. So that's what we are doing because based on this calculations, right? So we need to check inside this. Now, how we will do that? So now let's come to that logic. Okay, so we'll do that based on a few logics. Let's understand that. So what we call in that case, we call that as our cumulative sum. Okay, so we are doing what? We are doing a cumulative sum. Cumulative sum in the sense we are whatever we have value, we are just traversing based on that. Fine. Like we are finding a sum of previous value and our current value, whatever. Like the previous all the values and our current value. That's what we are doing. So what we mean, say our say just forget about the previous all the. Say we have a pointer I over at this position. Fine. So if we say cumulative sum of our I. Okay, so cumulative sum for I is like, if I'm just considering the first row itself, right? Let me just erase this off and just understand this in a single array itself. Let's not take a multiple array, fine. So if we have something like this, say we have a value like -2, then -3, and then 11. I'm just taking some random values, right? So first say we have our I at this initial position. So what is the cumulative sum of I? Cumulative sum of I will be our -2. Fine. If our I say I and I plus 1, so we'll say cumulative sum of I plus 1. Fine. So what is the cumulative sum of I plus 1? It's like -2 plus -3, that is like -5. Fine. So that will be cumulative sum of I and I plus 1. Say this the another variable, that is the cumulative sum of j. That's the last point I'm pointing at. So like I'm not doing I plus 1, I plus 2. So let's say this is I and the last variable we're pointing at j. So what is the cumulative sum of j? Fine. What if we're trying to find this? So what is the cumulative sum of j? Cumulative sum of j is like the sum of all the variables, right? -2, -3, and 11. So what is that? 8, right? So 11 minus 5. No, 11 minus 5 is like. I'm sorry, I just calculated this. Wait, yeah. So we are doing like 11 minus 3 is 8, minus 2 is like 6. 6 our cumulative sum till j. Okay, so that's what we find. Okay, cumulative sum of this much. Like the j, when I say cumulative of j, that means all the elements before this from the start. Fine. So if we're doing some kind of value like this, so what we need to do? Because if we're doing cumulative sum of all the values, then by sum we don't have a cumulative sum of this much element, right? So how will we check the cumulative sum of this much element? Say our value is like k equal to given as 8. Fine. If our value is k given as 8, so how will we go ahead with that? Our idea will be, see, if we do something like that, cumulative sum of j, fine, cumulative sum of j minus cumulative sum of our I, that is the first index. If we do that, then we get our cumulative sum of this much element, right? Right. So our idea, we should check in this order that if cumulative sum of j minus cumulative sum of I is less than equal to k, this should be our case, because we are subtracting this I value and we have this current cumulative sum. So this sum is it less than equal to k? If it is less than equal to k, then we need to check is it the max value, because we are trying to find the maximum sum, right? So is it the max value or the max value is already attained, like the current subtraction is not a max value. So we need to check for that. Fine. Then what further we should check? So see, if we just reorder this particular statement, okay, if we just reorder this, because we don't have cumulative sum of I in our hand, right? Right, we have cumulative sum of I, but we have cumulative sum of j, but we don't want this whole thing to be less than equal to k. Can I do in a different order? What I mean is, say we have our cumulative sum of j, fine, and this minus, so cumulative sum of j is easier to find. We just added 11 to our previous cumulative sum. So that's how we find cumulative sum. And minus this k, like bringing k this side, is less than equal to cumulative sum of I. Fine. So why we're doing this? Because we don't know the position of I. The I we marked it as the first position, but say there are multiple elements and we don't know which position to subtract, right? And we don't exactly know how much is our value we need to check, right? So if we need only this values, or like only minus 3 and 11 will do our result, or only 11 will come up to our result, or only minus 2 and minus 3 will come up to our result, we don't know that, right? So in that case, what we'll do, we'll simply go ahead with doing this kind of like this is our initial formulation, and we just reorder the statement. So see what happens when you reorder the statement. Now we don't need to find this cumulative sum of I. We can easily like we are actually finding this out because j is what we are currently at, and k is what we know, right? So see if 6 being our value we have, fine. If 6 being our value at j, and let's put some value. So 6 minus what is the k value? K value we took as 8. Fine. So is it less than equal to what? We don't know. So let us find out less than equal to minus 8, right? So like the 6 minus 8 is minus 2, right? So we need to check if like cumulative sum of I, is there any I whose cumulative sum is minus 2 or less, minus 2 or less, okay? So we need to check is there any I that is having cumulative sum minus 2 or less. We have that value over here, so we can find, okay. So if we have a value over there, like the cumulative sum of minus 2 is there or some less value is there, so we can easily find that less value minus like 6 minus that value will make up to our 8 or less than 8, less than equal to 3, like no larger than 3. So that's the idea over here. Fine. So that's how we are actually trying to find a solution. So once we get a solution like this, like less than equal to our cumulative sum of I, because we need to find out which cumulative sum we need to check for. Like so once we need to do that, so we do something like ceiling or floor, right? In our array or in our set, whatever we are taking, because this current value is like we should go ahead with the state also. So we need to check what the ceiling or the floor values we are trying to achieve, right? So once we are getting less than equal to, we'll go with the ceiling values, because we need to check the lesser value, lesser or equal value than our this subtraction value, right? So that's what we need to check. So that's our idea. I mean, that's how we are trying to find out our minimum sum. Like once we find a value like minus 2, like 6 minus 8 is minus 2, right? So once we find minus 2, now we'll check if there's any value like less than equal to minus 2 in our cumulative sum array. If there is any, it can be minus 2, it can be minus 1, or any other value lesser than that, fine. If there is any, now what we'll do, put that in our original equation. See what happens. Like original equation, CS of cumulative sum of j is like what? Cumulative sum up to j is like 6, fine. So we got 6, and then cumulative sum of I we found that as minus 2, fine. So minus of minus 2, fine. And we need to check, is it less than equal to what is our k? K value will be 8, fine. So 6 minus of minus 2 is 8. So 8 is equal to 8, and we find that's our answer. Like that's our value we are trying to look for. Like so that's the idea. That's the whole idea behind breaking into this. So this idea might become a bit complex, but this is what we call as a cadence algorithm. The cadence algorithm, as I said, when we go for like no larger element, like maximum Savary sum. Okay, so that's what we're doing. We're doing maximum Savary sum, and that's the cadence algorithm we're applying over here. Like as I said, we have two different problems, and we have to combine two different problems to be finding this bigger problem. There's a hard type problem we have over here. Fine. So in this case, what we do is like we simply find our solution based on this equation, like this particular equation we just derived. Fine. Once we find our equation, then we know whether we can reach our target or not, like how much far we can reach, and that's what we'll store. So the maximum value we will store in our maximum Savary sum of a single variable. It can be a single variable as well. So that's the idea. So this cumulative sum can be an array, we can take a set, we can take a map as well. So that's the whole idea, because we'll better go ahead with the set, because it may happen like in further questions we may find that if the cumulative sum is minus 2 for here, and then we find the next value of cumulative sum is again coming up to be minus 2. So is it necessary to like add minus 2 again and again and again to just find out if there is value less than minus 2 or not? There's no need. So we'll go ahead to set for that case so that we will store only unique cumulative values for us, right? So this is the idea. This is the idea. And let me just quickly write this code because this is a like not an easy idea to remember. So let me just quickly write this code and then I will again explain you how you should go ahead and like breaking through this question, how you should find a solution to this kind of questions. Okay. So let me just quickly write a code for you. So here you can see this is the solution that works pretty like good for us. Like this works for us. Okay. So for a question like hard type question, you should think on finding a solution that actually first works for you. Okay. Then you should go ahead with reducing the complexity or doing anything further so that it reduces the time complexity for us. Now, if we just look at the time complexity, so the time complexity is actually like this runs throughout our row. So row multiplied by row, what I'm saying. Like this runs throughout our column, like number of columns we have, and then this also runs for all of our columns. Okay, so column multiplied by column, and then this is a so, and then this is a third loop we have. So this is the, like runs for all the rows. So column into row, and then we are doing over here is like a log of row. Okay, so that takes a complexity of log of row. So it's like have a high complexity. You will see like column into row into log of row. So that's a high complexity we have. But this can be easiest expression you can come up to in the initial stage because you have to use you use Kadane algorithm over here to just find out the cases, and you use the maximum sum of rectangle conditions to just find out the maximum sum of rectangle you can reach up to. Okay, so that's the two things you just combine, two previous problems that you might have solved, and here you just find a solution. So what exactly we did? So this is the result we have. So the result is the exact result which is returning over here. Fine. And further we have like the left we took a left matrix and like the left pointer as you say, and here is our sum. So remember I was taking a sum array, a different array to just store the current sums we have. Fine. So store all of them. We are just taking those. So this is the sum array. So this is the row sum you can say. We are just coming up to because we are moving for each of the column, and each of the column we are taking the row sum we have. Fine. Cumulative sum. And further, what we are doing, we are checking for the right. So right is like the right pointer we have in our discussion, and then we have this small row for each of the like current right column. Fine. We are just adding what? We are just adding the current values of the row to our row column. Okay, so that's what we are doing. We remember that was the adding we are doing for each of the row. We are just adding our values. So that's what we are adding. So that's how cumulatively we are added all the values. Now we took a tree set, right? A tree set because we don't want repetitive values. Say we come across a few minutes back, I will tell the same thing that if we come across -2 two times in our whole discussion, and we need to check the lesser than -2, so it's no need to go for that. Fine. We will have a unique values in our set, and that will be like enough for it. And also, why tree set? Tree set is like it comes out in a sorted order. Fine. We just if we do ceiling or floor of the values, we simply know how many values are there below that. We don't need to check for the whole tree set to do that. Fine. So tree set by default gives us a sorted set. Fine. So that's how the tree set comes up. And then we just added 0 to our set because that's the initial value we just added to just have a like the state being working for us. Fine. Then what we're doing, we have this cumulative sum as a value, a variable that initially being to 0. Fine. And further, we took each of the value in our current row because we just did the current row being set up, and we are at our right column as well. Okay, the current right column, and this is the loop being going on. That's the current right column. Fine. So what we're doing, we are going for each of the values in our row sum, like okay. And what we did, we took out the cumulative sum of all the row values. We just keep on adding them. Now we are doing what? Say cumulative sum minus k. Remember that formula we derived? That cumulative sum of I minus like cumulative sum of j minus cumulative sum of I is less than or equal to k. And we just reverse the formula to become something like cumulative sum of j minus cumulative sum of like cumulative sum of j minus k is less than or equal to cumulative sum of I. But remember, we don't know that I just discussed a few minutes back that we don't know that I value. So what we're doing, we are subtracting this cumulative sum of j, there's a current cumulative sum, minus our k being the value given to us, right? So k being this value given to us. So we are subtracting this to just find out what we are trying to find out, our target value. What should be target value, and we should be finding lesser than that. So what is the target? Is actually we did like ceiling. So ceiling gives like less than equal to value. Fine. So we'll found any value that is less than equal to our subtraction. Fine. So that's what ceiling gave us. Now we have a target. Now what is the checking? We have checking like if target is not equal to null. What does that mean? If target is not equal to null, that means if there isn't a ceiling value present, then it should be null. That's what returns, that what is returns actually. Fine. The ceiling value. So if target is not equal to null, that means our result, like this there's no need to go ahead with finding our result, or no need to find out the result being like if our current sum is equal to less than equal to our k or not, like the final result being our maximum sum that we are finally about to return, like this is the final result we return. So if the target is null, then there's no result, right? So we'll simply add our cumulative sum to our set. Fine. And if the target is not null, that is there are some values that is less than equal to our cs minus k, like cumulative sum of j minus k. So that's present. So that's how we found our target. Now we found the maximum value being cs of j, the cs being cs of j. Fine. Minus target is actually what? Actually the less than equal to which value we reach up to the k. Okay. So it may be k being reached, or it may be a value lesser than k. This is the maximum value we reached up to k. Okay. So that's what we are doing. And we're finding which one is maximum. Is it like a previous result we have found a better result previously, or a current target, like cumulative value minus target is our maximum result. So we are storing the denoted result, and further after traversing from all throughout the whole array, like throughout the whole matrix, we just return the result. So this is the whole approach for us. Okay, so this is the whole approach, and that's how this approach works. Like I wouldn't say this is the faster solution or fastest solution, because I have already found a faster solution that is 32 ms, and you can see this is already possible. So this is not the fastest solution. So we can modify this, or we can do this kind of small tasks in multiple other functions, or we can use a DP kind of approach to remember those like smaller values, or the smaller like some summary sums. Okay, so that can be possible. So in that case, we can use, like we can reduce our time capacity. So that's actually possible. Okay, so that's the whole idea behind it. So I hope I can make you understand this particular code, like how we should apply approach to this kind of code. Also, that 32 ms solution, which I try to find out as a faster solution, I'll put that in the just check down the description. You will find the code, all the code. So I'll put that 32 ms solution also in our in my code. But you need to understand that. Okay, so I am leaving that on you. If you don't understand that, make sure you comment that on our LeetCode discuss section. I'll be help you out with that. Fine. So that's more or less the question. So I hope I can make it understand. Also, if you have any doubts, make sure in the comment section about this video. I'll be happy to help you out. So like this video and subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.